Hi friends, welcome to my channel. So let's have a look at today's daily challenge problem. So rack transform for an array. So here we are going to practice the data structure called set, right? So here, given an array of integers, so we want to replace each element with its rack. So here is the definition. So rack is an integer starting from 1. And the larger the element, the larger the rack. If two elements are equal, their rack must be the same. Rack should be as small as possible. So with this definition, basically it gives us the way how to compute the rack, right? So here we are going to start from the smallest. So then its rack would be 1. And then you find the next smallest one. So here 20. So you are going to increment the rack by 1. So if you have another 20, then the rack will be again 2, right? So here in example 2, it's a very special case. All the elements are the same, so the rack would be the same. But because here is only one unique element, so all the racks would be 1. So example 3 is a generic case, right? So you can first find the smallest one, which is 5. So it's going to have rack 1. And then you find the next smallest one, it's going to be 9, right? So then its rack would be 2. Then you just increasing that. So one observation from the definition is that, so if the elements are equal, then their rack must be also equal. Therefore, the only thing matters is the unique elements, right? So that's why the set comes into play. So here the order is also important. So if we can rack, we can sort the unique elements. It's actually, you can also see we can rack these elements, right? So it's very intuitive. So what we are going to do is first I'm going to get the unique element. That's the set function, right? And then I'm going to sort it. So we can directly call the built-in function sorted. So if you have a iterable, and then you use the sorted method, it's going to yield a list which gives you the sorted elements. So let's call it increasing because the default behavior is from small to large. So you can print out this. So for this example, you get 10, 20, 30, and 40, right? So now let's see. The 20 will have index have rack 1, and the 20 will have the 10 have rack 1, and 20 have rack 2. So you can see the rack, because it's starting from 1, it's like indexing this element starting from 1, right? So we can do something like this. We can make a lookup table. So let's call it racks. So what we can do is yi. So y is the element in the sorted sequence. I is the index. So for I, y in enumerate function. So the enumerate function, we're going to have a tuple, which is the index and the element. So what we want to index is this sequence increasing, inc, right? So but also we can pass a keyword argument. So this is starting point of the index. So because of the definition of rack, we start from 1. But if you do not ignore those, it's going to starting from 0, right? So now with this set, so you can just return. So I just need to map all the elements in the array to the corresponding values in the rack. So it's just the racks y for y in array, right? So this is actually a very verbose translation of this definition. So we can do a check, right? It passes this one. If we can pass the second one, we can expect it will pass all the test cases. So now let's do a submit, right? Yeah, it passes all the cases. But if you do not know, for example, here we can pass a starting index. It's also fun. Let me copy this one. I just make a very small modification. So I'm going to call this one version v1. So here I can ignore this one, right? So here the indexing will be starting from 0. In other words, it's not the rex in the sense of the current problem statement. But what you can do is here, you can just add 1. So rex y plus 1 for y in array. So it will have the same effect, right? You can submit that. So, but it's slower, it looks like. But the time complexity for sure will be the same. Yeah. So I guess that's basically about it for this easy daily challenge. So here, let me emphasize what we are using is actually the set data structure. In other words, we are focusing on unique values. So with that said, I guess that's it for the current video. Thank you.